Today we're looking at lesson 3.05, Give Me 5. And our objective today is I can correctly match 2 out of 3 functions to their features. Now before we get started with that matching today, we're going to do a little bit of practice in anticipation of today's assignment, or the one we're going to look at in Math Lab tomorrow. So we're just going to do some problems that should look like review problems. So the first one is find the indicated function values. They've given us a function and an equation for it. And they want us to find value of f of 2 first. So how do we do this? Well, we see that this 2 right here is replacing this x, right? F of x, f of 2. So we're going to substitute in the 2 for the x. Notice we have another x right here. So this is a substitution problem. We're going to put 2 in for x and evaluate. So we have 5, and then we have a space for the x, minus 3. So 5x minus 3, and I just put parentheses to make a space there. We're going to replace the x with the 2. We get 5 times 2 minus 3, so that's 5 times 2 is 10, minus 3, which is 7. Now on the second one, you'll see they didn't actually give us an x value now. They gave us a whole f of x. But we may remember that f of x is just another way to write y. This is like y equals 32. So this whole side of the equation is going to equal 32, the y value. So we can write 32 in place of it over here, and then write the rest of the equation. 32 equals 5x minus 3, because f of x equals 32. And now we just need to solve for x. We can add 3 to both sides. We get 35 equals 5x. And then what is our next step? We're going to divide by 5 because we're multiplying by 5. So opposite operation to get rid of 5. We get 35 divided by 5 is 7. 7 equals x. So it's asking what x equals here. X equals 7. And on this third one, look at this and determine, are they giving us an x value or a y value here? Looks like they've given us a negative 8. Is that x or y? This is replacing the x value in f of x, f of negative 8, f of x. So this is our x value. We're looking for y. We're going to have 5, leave a space for x, minus 3. I'm putting negative 8 in for x. So 5 times negative 8 minus 3. 5 times negative 8 is negative 40. And negative 40 minus 3 is negative 43 is our answer here. On to the next page. We have some similar questions. Looks like these are formatted pretty similarly, but now we have a graph instead of an equation. So we need to evaluate a function based on a graph instead of plugging it in. So let's look at A here, g of 2. What is the g of 2? How do we figure that out on a graph? Well, this 2 value, again, is going to be our x. So we need to go, on this graph, we need to go find where x is 2. This is our x-axis. It goes left and right. We find where x is 2. Well, that's 1, 2 right here. And now we need to go match that to the function. Where does the function meet x equals 2? Well, looks like it's right here. So if x equals the function, x equals 2 meets the function right there, what is our y value? Our y value right there is 1. So the answer here is 1. And we got that just by reading the graph at x equals 2. How about g of x equals 4? Well, they didn't give us an x value, so they must have given us a y value. That's really the only thing they give us in these problems. We only have an x or a y. So this is the same thing as y. G of x, same thing as y, equals 4. So now we just need to go to the other axis, right? We need to go to the y-axis and look for 4. We're going to go the other direction. So here's our y-axis. We're going to go up to 1, 2, 3, 4. And we're going to ask, where on this line 4 does the function cross it? Oh, well, it's right on the y-axis, actually. It crosses right there. We don't have to go left or right. So what's our x value there? What's our x value at the y-axis? Oh, it's 0. We're not left or right at all. That's just 0 right there. So x equals 0. And our last one, once again, this is an x value they're giving us. They've given us x equals -1. So we need to find where x is -1 on this graph. Look at our x-axis. We go to 0, -1, and we go match that to the function. The function exists right about here at -1. So what value is that? Well, here we have 5, 6, 7, 8. So it looks like that evaluates to 8. So that's evaluating a function from a graph. Let's look at a couple more problems here. This asks, are these contexts discrete or continuous? The first one says the amount of water in a pool that is being emptied. So we've got water flowing out of a pool over time. Does that make you think discrete or continuous? Well, we do know that water almost always is continuous. It's an example we use of a continuous flow of something, right? It doesn't happen in chunks. It just kind of flows continuously. We know that time is continuous, so we might conclude this is continuous. Another way you might think of this is thinking, can we divide it in half? Is there such thing as half a gallon of water? That's kind of an amount of water, right? A gallon. Can we have half a gallon of water? Can we have 1/8 of a gallon of water? Sure we can. How about 1/100th of a gallon of water? Yeah, absolutely we can. We can divide water up continuously, and it always makes sense. It makes sense to divide water more and more and more and more and more. It's still a valid volume of water. So then we conclude it is continuous. Okay, but how about the number of runs scored at a baseball game? Is that discrete or continuous? Well, those happen in chunks, right? You don't get a part of a run. You don't get half a run. You don't get a quarter of a run or 1/100th of a run. You either get a run or you don't. So that happens one chunk at a time. One. So this is a discrete context. We can't divide that up, and it's not happening continuously over time. So that is our practice for the assignment tomorrow. For today, we're actually going to look at the quiz. So we don't often do the quiz in class in this one, or in here, but we will look at it today. And you will be matching functions to their 5 features. You'll have a list of functions in one column, and then you'll have a list of features in another column. And you need to match the function to its feature. We will look at the first one together, and then you can do the next ones on your own. You can pause the video and do that, and then we will come back together and look at the answers. So here is the first one we're going to look at together. Here's our function. Looks like it's a graph. It looks linear. It's a straight line. Has a closed dot down here has a closed dot up here, so we're going to include those endpoints. So let's look at these lists of features now. Let's look at A. Now, on the quiz, you'll have 6 options. You'll have 6 functions, or 6 options in the function column, 6 options in the features column. But a hint here is you might be able to narrow it down to just 3 because some of them only have one function. Some of them only reference an f of x, and some of them have 2 functions. Some of them also have a g of x. And if you look at the ones that only have a single function, there are actually only 3. So that's a good way to start to eliminate your options here. So let's look at A first and see if these match. F of 1 is greater than f of 2. Remember, alligator eats the bigger one, so this should be bigger, f of 1. Okay, so f of 1 is going to be where x equals 1. Here's the x-axis. X is 1 here. And let's go up to the function. Here's f of 1 right here. Then f of 2 is going to be where x equals 2, right here. And the question it's stating, or the assertion it's making, is f of 1 greater than f of 2. Is this one bigger than this one? No, that is definitely not the case. This one's smaller. You can see it's lower. So this is not true. We can already eliminate A. It does not match this graph. Okay, so let's look at B then. F of 2 equals 6. That's our first assertion. Okay, so x is going to be 2. We're going to go onto the x-axis and go 1, 2, and go up to the function and see where it matches. Looks like we already drew a dot there. This y value is 5, 6. So f of 2 is 6. We just confirmed that. It also says f of x equals 3 at x equals 0. Okay, so let's find x equals 0 on the x-axis. That's right here. And we need to find what f of x is. So we're going to go up to the function, find where it crosses. Looks like that is 1, 2, 3. The value is 3 there. So f of x does equal 3 at x equals 0. That is true. Okay, how about the next one? The x-intercept is -2, 0. The x-intercept is where the function crosses the x-axis, which is right here. That's where it crosses. Is that point -2, 0? Let's see. -1, -2. Yep, that's right. And then there's no up or down, so this is in fact -2, 0. That is accurate. Now in these matching problems, you can go through all 5 options and make sure they match, and it's generally a good idea to do so. But if we have a multiple choice like this, we don't necessarily need to go through all of them. If we can eliminate C at this point, we can probably be fairly certain that our answer is B. And we'll save ourselves a little bit of time by evaluating these additional features. So let's look at C really quick and see if we can eliminate this one. F of 5 is less than f of 6. Is that true? Well, let's see. F of 5 is right here. F of 6 is right here. So f of 5 is in fact less than f of 6. That is accurate. Uh-oh. Looks like we've got matches on 2 of them now. Let's look at the second one. The domain of f of x is 0 to 15 inclusive. We're going to include those endpoints. Is that the domain of this function? Think to yourself, what is the domain? Think back to our song, the set of inputs is the domain. Our x values, our valid x values for this function is the domain. So what are those? Well, looks like this is where our x values start, and they come all the way over here to here, and they're closed dots on both sides. We fill it in between. There's our domain. There's the interval that is our domain. And that looks like -1, -2, -3, -4 here. -4 to 6. -4 to 6. It's going to be our domain. Does that match this? 0 to 15? No, that should be 0 to 15 would be out here. That's not where this function exists. So that one is not accurate. That one doesn't match. So now we're pretty sure this is probably B. We can go through the rest of them and make sure. The range of f of x is -3 to 12. The range is our outputs. The set of inputs is the domain. The set of outputs is the range. So let's look at our valid y values here. It starts down here, goes all the way up to here. That's our top y value. We're going to look at the numbers in between. That's -1, -2, -3, all the way up to 11, 12. So -3 to 12, that one works. That is our range on this one. And the last criteria is f of x is greater than 0 for -2 to 6, that interval. And I think this should actually be a square bracket. F of x is greater than 0 on the interval -2 to 6. Well, let's see, -2 to 6, that -2 is right here, up to 6 here. So this interval, this subset of the function, should be positive, should be greater than 0. Well, you can see it's above the x-axis, so yeah, that is positive. That one checks out too. So this one matches to B. Remember that on your quiz, the OLS might mix up the order of functions, so you won't necessarily see them in this order. But look for the one that has the line, like this, and then look for these functions. That's the match. These features of functions. So now you can go take a try at the quiz, pause the video, go try the quiz, and see if you can answer the rest of them. If you can, you don't need to watch the rest of the video. You are done for the day. Get 100%. Have an awesome day. If you have trouble with it, come back to the video and we will go over those problems. So go pause the video right now, go take the quiz, come back if you need to. All right, so let's go over those problems. We already looked at one of these. We said this one matches, 1 to B. Let's look at number 2. This one has kind of a curvy line. It goes up first and then down. Let's look at the features in A. F of 1 is greater than f of 2. So we're going to go to x equals 1 up to here. That's where it meets the function. And then f of 2, x is 2, that's where it meets the function right there. Is f of 1 higher than f of 2? It sure is. Yeah, that's accurate. F of 1 is greater value. That means f is decreasing at that point. Okay, how about f of 3 equals 4? Is that true? 1, 2, 3, that's our input right there. And we go up to where it meets. Meets right here. What's the value? That is 4. Awesome. So that one worked. Maybe let's try one more. F of x equals 2 at x equals 1. So x equals 1, let's go find that. Which our x-axis over to 1. We go up to where it meets the function right here. We already have a dot there, and it looks like the value is, in fact, 2. So we've confirmed 3 of them already. This one's looking pretty promising. Maybe let's just look at 1 over here and see if it's accurate. How about this first one? F of 5 is less than f of 6. Is that true? Well, if you look over here on the graph, f of 5 would be right here. The function doesn't even exist over here. This isn't part of our domain. F of 5 and f of 6 are undefined on this function. So This can't be true. So we've already eliminated C. B is already taken by 1, so A is the only one left. This must be our match for number 2. Which means the only single function option left is this match right here, 3 to C. Let's just look at 1 or 2 of these, make sure they make sense. F of x represents the relationship between the number of gallons of gas purchased, x, and the amount paid for gas, f of x. So we're talking filling up a car with gas. And you can think about, just in general, what that might look like. There's a certain amount you pay per gallon of gas. You can expect as you get more gallons of gas, you will pay more. You can think to yourself, is this going to be linear or exponential or neither? Let's see, we're going to add, say it's like $3 per gallon. We'll add $3 for a gallon, add $3 for another gallon, add 3 more for another gallon. Sounds like arithmetic. That sounds like linear. So we're going to expect it to be some kind of graph that looks maybe like this, like a linear graph. So f of 5 is less than f of 6. Is that accurate? Or another way to ask this is, would you expect to pay less for 5 gallons of gas than you would for 6 gallons of gas? Yeah, it's not a trick question. You absolutely would, right? We would expect to pay less for 5 gallons of gas than we would for 6 gallons of gas because you pay money per gallon. The domain of f of x is 0 to 15 inclusive. Well, let's see. The domain is the input, the number of gallons of gas purchased. What's the valid inputs for that? So I think what it's telling us here maybe is that you can put in 0 gallons of gas, you can put in 1, you can put in 2, you can put in 2.5, you could put in any number up to 15. Why do you think it might stop at 15? Well, 15 is actually a very common size of a car's gas tank. That's sort of the limit of what a gas tank can hold. So this one checks out as well. That fits with the story. Because that's true, you can fill up the gas tank anything between 0 and 15 gallons. F of x has a constant rate of change of 3. Yeah, sure. Like we said before, if this is $3 a gallon, then we're adding 3, adding 3, adding 3 each gallon we put in. So that makes sense. F of 0 equals 0. So if you got 0 gallons of gas, you pay $0. That seems right. We probably don't even need to check this last one. We could. F of x has an absolute maximum at 1545. Well, that makes sense. We said our upper bound of our domain is 15, right? So that checks out. And then 45, well, that's going to be 15 times 3. We said this was the rate of change. So yeah, that sounds right. If we put 15 gallons of gas in the car, we pay $45, and that would be the max we could possibly pay. So these all match like that. That one checks out. We are good. So let's look at the other 3 now, the other ones that have 2 functions involved. This first one shows us a graph. Looks like we have a parabola and a straight line. This one's a table with 2 functions. And this one is 2 functions in 2 equations. We're going to try to match these up. So let's look at number 4 first. Let's look at this graph. And start with D down here. F of x equals 0 at x equals 1. Is that true? Let's find where x equals 1. Here's our x-axis. Go over here to 1. F of x is our blue line here, so f of x meets right there. Is the value there 0? Is f of x 0 at that pink dot? No, it's 2. It's at 1, 2. So this is not true for number 4. Okay, how about number 5? I mean, not number 5. How about part E, I mean? Let's look at 4 compared to these features. F of x equals g of x at x equals 0. Is that true? Well, okay, let's go to the x-axis, x equals 0. Do f of x and g of x equal each other here? No, they don't intersect. They're at different values. They're at different y values. So no, this is also not true. The only one we have left is f. So let's check one of these. F of x equals g of x at -2, -1, and 3, 4. So we're looking for two places where these intersect now. Well, looks like we have an intersection right here and an intersection right here. Do those points match? -2, -1. That's going to be -2, -1. Yeah, that one matches right there. And then 3, 4. 1, 2, 3, 1, 2, 3, 4. Yeah, that one matches as well. Okay, so that's good. That looks like it checks out. Maybe let's try another one. F of x is greater than g of x on -2 to 3. Is the line of f of x above g of x? So let's see. -2, we have -1, -2. It's right here. You can see it meets at that dot right there, -2 to 3. So here's 3. So this interval right here, from here to here, is the line f of x above g of x? Well, yeah, you can see g of x scoops down here, and f of x is above it. So f of x is greater than, alligator eats the bigger one, f of x is greater than g of x on this interval. So that is true. That's accurate. It's looking like we're going to say number 4 matches f over here. We could go through those other additional features, and I encourage you to do so. But we're just going to move on and try to figure out which one matches over here. So just erase those little x's, and let's look at number 5 now. Let's see if 5 maybe matches D. So f of x equals 0 at x equals 1. Let's see if that's true. X equals 1, so x, go down to 1. We're going to look at the f of x column. Is that 0? It is. That is 0 right there. That is a true statement. Okay, how about f of x is increasing on 2 to 6? So we're going to look at the interval from 2 to 6 of the x values. We're going to ask, is f of x getting bigger there? 0, 2, 6, 12, 20. Looks like it is. It's going up. So that is accurate as well. How about g of x is greater than f of x on 0 to 6? So here's our interval again, 0 to 6, and we're going to compare g of x to f of x. You see 7 is bigger than 2, 11 is bigger than 0, 15 is bigger than 0, 19 is bigger than 2, 23 is bigger than 6, 27 is bigger than 12, and 31 is bigger than 20. So yes, all of those points, or all of those values, agree with that assertion. G of x is greater than f of x for this entire interval right here. So this is looking pretty promising. I'm going to guess that these ones are probably matched. Let's see if we can eliminate E for number 5. F of x equals g of x at x equals 0. Is that true? Well, here's x equals 0. Here's f of x. Here's g of x. Are those the same value? No, they certainly aren't. So E we've already eliminated. It's got to be D. It's got to be D to match this. Okay, so our last one, we're going to guess is probably going to match here, but let's at least check one or two of these to make sure it works. F of x equals g of x at x equals 0. Oh, well, let's plug in 0 then. G of 0 is going to be 2 to the 0, which is 1. Anything to the 0 is 1. And then f of 0 is going to be 3 times, plug in 0 for x, plus 1. So 3 times 0 is 0, plus 1, that'll be 1. So 1 does equal 1. That is accurate. How about this one, number 3? F of x and g of x increase from negative infinity to positive infinity. What does this graph look like? If we were to graph this against each other, 2 to the x, we know this is a typical exponential. It looks something like that. And then 3x plus 1, we're going to have y-intercept at 1, and then we're going to have a fairly steep linear line like that. So you can see our line, this one's the line, f of x is the line, this is f of x, and our curve here is g. You can see both of these are going up to the right. Right? They also both go down to the left forever. So this interval is negative infinity to positive infinity. It's going to go to the right forever, it's going to go to the left forever. It's going to go down forever, it's going to go up forever on this side. So yes. Oh, sorry, we're over here. F of x and g of x increase on the entire interval of the graph. That is accurate. How about number 4? F of x has a constant rate of change and g of x has a constant growth factor over equal intervals. We know that's actually true. This is constant rate of change, that's slope. We know that's a linear equation. This is also a linear equation, so yeah, that's true. Constant growth factor over equal intervals, well, that's our common ratio. Growth factor is what we're multiplying by. That's 2. So g of x is an exponential, and that fits. Yeah, it definitely looks like this is the proper answer for these equations. So get those all matched up on your quiz. And that wraps it up for today. I can correctly match 2 out of 3 functions to their features.